There is something very strange going on in artificial intelligence. There are some people who think that superintelligence is around the corner and that it will soon be there and will supersede the human species. And on the other hand, there are many people who are very skeptical about AI, and especially about natural language processing or computational linguistics, because they say it's more artificial stupidity than artificial intelligence. So what I want to do today is to explain to you where this opposition comes from and what we can do about it. And I will also try to give you a bit of advice on how to properly use this technology, which is so important these days. So the rise of artificial intelligence, the current hype that we have today, is mainly due to a machine learning method called deep neural networks, which is very loosely based on how the brain works. Very loosely based on that. But nevertheless, it has achieved an enormous amount of very spectacular results in all areas of artificial intelligence. Not only in natural language processing, but also in areas like robotics and areas like image processing. And actually, you can see that for yourself. If you look at YouTube movies, you can push the CC button, and what you will get there then is a transcription of what is being said on the YouTube movie. This is actually two very difficult technologies that are being combined. The first technology is speech recognition, so trying to get from speech to text, and the second one is translation, text in one language to text in another language of your choice. You can actually choose among all the different language pairs that Google Translate offers to you. So that's a spectacular application. There has been a lot of progress. Every year, this system is getting better, and other systems that make use of it. So that's really good news. But you might also have tried to use Siri and Alexa and all these other conversational agents or these conversational assistants. And then you might run into a number of problems. So they are very good at doing very simple things, but they don't really understand what you are saying, and they are especially very bad in taking context into account, as you see an example here on the slide. To explain why these two different types of application are so different, I have to take you back a while to the history of computational linguistics, the history of AI, which started in about the 60s and the 70s. And the first thing to notice is that already at that time, all the different methods, all the different techniques that we have been using the last 60 years, well, not me personally, but people in the AI community, all these techniques already existed from the start. So what has changed? What has changed is an exponential growth in computing power and an exponential growth in machine-readable data. So data that these systems could use to make their own models. So at the start, people had to handcraft their models. They had to really build it from scratch with insight and with a lot of knowledge about the domain. And they actually built very interesting and sophisticated systems, but they didn't scale to real applications. They didn't scale to things that commercial companies, for example, were interested in. So we had to wait until the mid-90s to be able to use machine learning methods and statistical pattern recognition techniques, which look at a lot of data and then extract patterns from that, extract knowledge from that themselves. But even then, it took a lot of effort on the part of the researchers to prepare the data, to select the data, to find the data, to annotate the data. There was a lot of pre-processing, a lot of design, a lot of engineering still involved in these systems. Okay, now we go further, 20 years of exponential growth of computer power, and we are at these deep learning systems, at these deep neural networks. And one particular example of that is GPT-3, which you might have heard of, which is a model that is trained on 500 billion words of internet data. So it crawls the internet, it takes all this text data from the internet, and then it builds a model, very simply by predicting the next word given the previous few hundred or thousand words. It predicts the next word. Very simple and very far removed from what we think would be artificial intelligence. But nevertheless, the patterns that it learns are not only about language, but also about the knowledge of the world and about information that the system can get from all these texts, even about coding and programming. But applications like machine translation, summarization, question answering, then really reduce to fine-tuning this large, huge monster of a model into these different applications. So that's the history that we have seen. And the fact that we don't have good conversational agents makes me think that this is not really the way that we will have really intelligent conversation with computers. It might be sufficient to learn all the translation patterns that we need to translate, for example, between English and Spanish. Because there's so much data, it sort of remembers most of the information that it needs, and by a very simple recombination of these patterns, it can learn interesting stuff and do real machine translation at a level that is very close to what humans are capable of these days. But the fact that these methods don't work for conversational analysis makes me think that we can have another 20, 40, or 50 years of exponential growth in data and computing power. We will never get at the sort of theory that we really would call intelligent. So that explains the difference between these two. But of course, we could say, okay, we do automatic translation. We can fire all human translators now. We can trust this model. Luckily, that is also not the case because of this reason. In this timeline that we have seen the last 60 years, we have seen an enormous growth in accuracy of the models, but at the same time, there has been much less control in what the model actually knows, what it understands, what it has extracted as patterns from the data. There are some techniques that can help you to analyze that, but these are really early days and not really very complete. And I will show you what this can bring to you. So actually, this pattern was never put into the machine, so it has picked that up for itself. And I remember 7 or 8 years ago, when this paper appeared, everybody was really very impressed by this. So these systems can learn by themselves that analogies of the type man is to king, like woman is to what, and then you could derive from the system, infer from the system, queen. So far, so good. But you also see other patterns appearing that nobody put in the system, but that nevertheless come out of it. Patterns of the type, father is to doctor, as mother is to what? Nurse. Okay, perhaps that's not the type of inference that we want our models to make. And if we want to use that in machine translation, then it might get you into trouble, because a doctor will always translate it into Spanish as the male version and not as the female version. So there's a lot of work to do. How is this possible? So how can it learn a lot of stuff which is very useful, but also a lot of stuff which is biased, which is not really what we want? I think the explanation is that there's no real connection with reality of these models. They don't learn by perceiving reality. These systems learn by having a second-hand representation of reality, which is the text that all these people have written, all these translations that people have written. So it's actually recombining the cognition of thousands, perhaps millions of different people who have written text, and it's trying to make sense of that. But a lot of what comes out of this type of generalization from that data will be hateful, will be spiteful, will be sexist, will be irrelevant, will be plainly wrong information. So we should be very careful with how we use these systems. And so my advice would be, if you use machine translation in an area where it really matters, like legal context or medical context or any other context where you need very precise translations, then you should really use a human in the loop. There should be someone who takes the output of the system and really scrutinizes it for any possible problems that you can find. So a lot of progress there, but still we are not there yet, I think, because the models have not really learned from themselves, but have learned second-hand knowledge from a lot of different areas. Another area where artificial intelligence is used a lot, apart from machine translation, in natural language processing these days, is in profiling people. So we have done a lot of work at the University of Antwerp also in that respect. So we have built software that can analyze, for example, tweets from a lot of people or from one particular person. And then we can derive information of the type, of the gender, the age, the personality profile, the educational level. All this type of information, we can derive that, and we can guess that simply by analyzing the text that these persons have written. And I've picked a random person here, a certain Jeroen. And so we use software here from our spin-off company, TEDxAntwerp, spin-off from the University of Antwerp, to analyze what Jeroen has been tweeting about, and then we can make a profile of the time that he's a man, he's an adult, he's, I think, rather critical, at least in the latest tweets, and he's extroverted, and a lot of other stuff that we can guess from the texts that he has written. Now, I hear you thinking, okay, this is really like astrology, right? So it's a bit like just guessing, and you will find something which is correct, and you will find other things which are not correct. But it's actually not like that. So we did, under laboratory conditions, we did all the experiments methodologically correct, and what you find is that you can predict these profiles for between 60 and 80% accurately, depending on the kind of information that you want to derive. So that's very useful, but I think not useful enough to be able to use this type of information to really judge one person. For example, to make a hire or fire decision, or to make a decision about whether someone can enter some club or whatever. So you can't really use this information because you will be wrong 40% of the time, in the best case 20% of the time. But what you can do with the current state of the art of artificial intelligence is to do what we have done, which is, and you can still, it's still up, you can look at this website if you want. What we did is we analyzed tweets and Facebook posts by people who were anti-vaccination, so anti-vax people and vaccine-hesitant people. And then, because we are working with large numbers of people, we can actually have trends analysis. We can see the majority of the people there, what they are thinking. For example, where they are living, even, so where the hotspots are for vaccine-hesitant people. But we can also see what their motives are to be hesitant. And the two main motives these days are freedom. They want to be free to choose. And the second most important argument is a distrust of authority, both the scientists and the politicians. And that is the main reasons. Not that, for example, that they don't think they think it doesn't work. So that we can learn a lot about these trends. And going back to the profiling, so here we have also a profile of the average vaccine-hesitant person. It's a man, an adult man, who is extroverted, but that might have to do with the fact that he tweets a lot. And also someone who is lower educated. So we can't say anything about a particular person, but we can say something about a large group of people by doing this trend analysis. So in conclusion, I think that artificial intelligence has, especially in my field, natural language processing, has advanced a lot and is really useful in a number of applications, but not perhaps in the way that you think, or that people normally think it's available out of the box and you can use it just like that. You really need these people in the loop who are domain experts who can actually interpret the results of an AI system and correct it if it's using the wrong information. And the most important lesson, I think, is that way back in the 60s, we took one route to artificial intelligence, which is the one of having a lot of computing data, computing power, a lot of data, and having the system learn from themselves. Perhaps we should go back to the 60s and take a few different routes to different solutions to solve the problem of artificial intelligence. Thank you.